So very good afternoon Nanda. So today lecture video we will discuss about the topic is power diode. So these are um, the course outcome is explain the operation of various switching devices and the dynamic characteristics and learning outcomes are explain the construction and the characteristics of power diode. So session outcome is understand the reverse recovery characteristics and construction operation of power diodes. So these are the outcomes. Uh, then, so what is a power diode? So power diode is a type of diode that is commonly used in power electronic circuits. Just like a regular diodes, the power diode has two terminals and conducts current in one direction. The power diodes varies in construction from standard diode to enable this high current rating that is called as a power diode. So next, some of difference between a signal diode versus power diode. So signal diode voltage ratings are plus or minus of 15 volts. It will handle the voltage ratings plus or minus 15 volt, and power diode handle the in kilovolts. Uh, and current rating of signal diodes microamps to only handle the microamps to milliamps. In power diodes handle the few ampere to some kilo amperes. And third parameter is the power rating. So signal diodes only handle the milliwatts to some watts, but power diodes handles the watts to uh, few watts to some kilowatts. And fourth parameter is symbol of signal diode is this one. The consists of anode and cathode terminal. Power diode also consists of anode and cathode terminal. For structure wise, it consists of PN junction. So PN junction formed when P-type semiconductor or physical contact with a N-type semiconductor. So P region has a greater concentration of holes where N regions has a more electrons concentrations. So P regions have free electrons called as a majority carriers and free electrons are minority carriers. In this N region, free electrons are called as a majority carrier, whereas the free holes are called as a minority carriers. So doping densities in a p-type semiconductors may be different. So this is a construction of power diode. It consists of p plus region and n minus region and n plus region. So these are the basic difference of signal diode versus power diodes. So next one is a um, signal diode. So signal diodes are the simplest semiconductor devices having only the two layers, two terminals, and two terminals are one is anode terminal and is another is a cathode terminal and one junction. This is a junction. And the ordinary signal diodes have a junction formed with p-type semiconductor and n-type semiconductor. This leads to joining the p-type is called as anode and another side is called as a cathode. This is a construction of signal diodes. This region is called depletion region or space charge region. Next one is a power diode construction and operation. So power diodes are the similar to the regular diodes, although very slightly in their constructions. The regular diodes are also known as a signal diodes. So doping level of both p side and n sides is the same. Hence, we call as a p-n junction diode. So, doping densities in a P type and N type semiconductors are same, hence it's called as a p-n junction diode. But power diodes have, we have the junctions formed between the heavily doped P plus and lightly doped N plus. So, this is a power diodes are different in structure with from signal diodes. So heavily doped P plus junction and lightly doped N minus layer, which is epitaxially grown on a heavily doped N plus layer. This is a heavily doped N plus layer. This is also heavily doped P plus layer. This N minus layer is epitax epitaxially grown. Epitaxially grown. So this is a construction of power diodes. So consist of P plus, N minus and N plus. So the power diode should be should be designed as to handle a high forward current and large reverse breakdown voltage in. So this N minus layer is a basic structural feature is not found in the signal diodes. The function of N minus layer is to observe the depletion layer of the reverse biased P plus and N minus P plus and N minus junction. So breakdown voltage needed in a power diode governs the thickness of N minus layer. So greater the breakdown voltage, more the N minus layer thickness. So N minus layer is lightly doped, nearly intrinsic. So lightly doped, intrinsic. So because this reason, N minus layer is sometimes called as a I minus layer and the device as a PIN diode or pin diode. So net charge neutrality of the space charge region is still maintained as was case in the signal diode, but the thickness of space charge region is quite high and deeply penetrated in the N minus region. So, the drawback of N minus layer is to add the significant ohmic resistance. So this is due to lightly doping concentration, as we know that thickness of space charge regions increases with the decrease in doping concentrations. This increases thickness of the depletion region or space charge region helps the diode to block larger reverse bias voltage and hence we have a greater breakdown voltages. However, the N minus layer significantly increase the ohmic resistance of the diode, leading to more heat generation during the forward conduction stage. Hence, the power diodes comes to various mounting for proper heat dissipations. Thank you.